Deepseek has a new model out, and within about 6 hours, the internet had settled on the wrong question about it. The question everyone's asking is, how do I run it locally? The question almost nobody's asking is the one that actually matters. Can you? Because here's the number that decides it. V4 Flash is a 284 billion parameter model. And if you've watched anything on this channel, you already know what that means for memory. We're going to do the arithmetic in a minute. And the answer is going to disqualify most of the people watching this video from running it on their own hardware. That's not a criticism of the model. It's an enormous, capable, permissively licensed model. And the thing that makes it interesting is genuinely interesting, but I would rather spend 20 minutes telling you the truth about what your machine can do than 5 minutes showing you a setup that will swap your laptop to death. So here's the plan. What V4 Flash actually is, in specifications rather than adjectives. The active versus total split, which is the whole story here, and which most coverage gets backwards. Then the honest hardware math, tier by tier, so you can find out in about 90 seconds whether local is even on the table for you. Then, because for most of you, it won't be every legitimate free route to using it anyway, which is the part that actually gets you to the model today. What the million token context window is genuinely for, why the license matters more than any benchmark, and the honest limits. One note on standards before we start, and it matters more than usual today. This is a fresh release, and fresh releases are where bad information spreads fastest. So, there are no benchmark scores in this video, no pricing figures, and no tokens per second claims. Not because they don't exist, but because I couldn't verify them to the standard I hold myself to before recording. What you're getting is architecture, arithmetic, and access. 3 things I can stand behind. Everything else, I'll point you at the primary source and you can read it yourself. Confirmed versus reported. As always, let's go. What V4 Flash actually is. 4 specifications, and every one of them matters for a different reason. 284 billion total parameters. That's the size of the thing. Big, not the biggest we've covered this year, but firmly in the class where just download it stops being casual advice. Roughly 13 billion active parameters. This is the number that makes it interesting, and we're going to spend real time on it. MIT licensed. About as permissive as software licensing gets. Use it, modify it, build a commercial product on it. No conditions worth worrying about. MIT is the license Deepseek's model line ships under. I pulled one of their model repositories this morning, and the badge is right there. And confirming it on the V4 Flash weights page is a 30-second formality I'd still do. Hold on to this one. I think it's the most underrated fact in the entire story. A 1 million token context window. Enormous and useful in specific ways that we'll get concrete about rather than just saying, wow. And the name tells you the positioning. Flash is the fast, efficient member of the family, not the maximum capability one. That's a deliberate product choice, and understanding it saves you from evaluating the model against the wrong standard. Flash models are built for volume, high throughput, long context, sane economics, rather than for topping a leaderboard. Judge it on that and it makes sense. Judge it as a frontier flagship and you'll be confused about why it exists. And the honest caveat stated plainly, verify these specifications against Deepseek's own documentation before you make decisions on them. I've linked their API docs and their model repository below. That's not a disclaimer for legal reasons. It's how you should treat every number in every video about a model that launched this week, including this one. What I actually checked myself before recording, and the distinction every fast video today is missing. Because this is release day and release days are when bad information travels fastest. I went to the primary sources before writing a word of this. Here's exactly what I found, so you can weigh my confidence properly. I went through Deepseek's official GitHub organization directly. It's active, their infrastructure projects are getting commits, their model line is all there. The Coder series, the V3 series including the latest experimental release, R1, the Prover, and Math models. And their release pattern is consistent and visible right in those repositories. GitHub hosts the documentation. The weights themselves ship on their Hugging Face organization with the MIT badge on the model line. Here's what I did not find there. A V4 repository. Interesting for V3 and R1, they made one. So I went a layer deeper to the place that can't be wrong about what's actually being served. I pulled the complete source of the open source gateway we've covered on this channel, the one that routes across hundreds of providers, and searched its live model registry. And that settled it. V4 Flash is in there as a served model on Deepseek's own first-party API and on more than 10 independent hosts. Better still, 2 of those providers serve exclusively open models hosted on Hugging Face, and both list it by its exact Hugging Face ID, which means the weights page exists from the ecosystem side, independent of any announcement. The registry even documents free pools for it, including a 1 million token starter credit at one host. And I genuinely enjoyed this. Flags those free pools with a terms of service caution tag. Even the routing infrastructure agrees with the standing rule on this channel. Read the terms before you lean on a free tier. One distinction still worth holding because most of today's coverage merges it. The announcement everyone is citing is Deepseek's API changelog. So V4 Flash is out, formally means the hosted service reached general availability. The open weights are the ecosystem's corroborated fact rather than today's headline. Both are true, they're just different events, and knowing which is the difference between reporting and repeating. Total cost of all this checking, about 20 minutes. Every channel covering this today had the same 20 minutes. Active versus total, the part most coverage gets backwards. This is the single most important concept in modern AI hardware, and once it clicks, half the confusing model announcements you read suddenly make sense. Older models were dense. Every parameter fired for every token. 200 billion parameters meant 200 billion multiplications per token, and the arithmetic was brutal and simple. Modern large models are mixtures of experts. The model is divided into many specialized subnetworks, and for each token, a router picks a small handful of them. The rest sit idle, which produces two completely different numbers doing two completely different jobs. Total parameters determine memory. Everything has to be available. You can't predict which expert the router will want next, so the whole model needs to be somewhere it can be reached quickly. Active parameters determine speed and cost. Only the selected experts actually compute. That's where your tokens per second comes from and where your electricity goes. So V4 Flash at roughly 284 billion total and 13 billion active is doing something specific. It holds the knowledge of a very large model while computing like a small one. 13 billion active is in the same neighborhood as models that run comfortably on enthusiast hardware. That's the trick, and it's genuinely clever engineering. And here's where the coverage goes wrong. People see 13 billion active and conclude, so it runs like a 13 billion model. It computes like one, it does not fit like one. Those are different constraints, and the one that stops you is memory, not compute. That distinction is the entire video. Let's do the arithmetic. The honest hardware math. Standard rule from our hardware guide. At 4-bit quantization, the quality sweet spot, a model needs roughly half its parameter count in gigabytes. 284 billion parameters. Half of that is 142. So you're looking at something on the order of 140 gigabytes of memory, plus overhead for your context window, your operating system, and everything else your machine is doing. Now let's walk the tiers honestly. 8 gigabytes, no GPU. No, not close. You're roughly 17 times short. Anyone telling you otherwise is either talking about a distilled derivative, a smaller model trained on this one's outputs, which is a legitimate but different thing, or they haven't done the multiplication. 16 gigabytes? No. 24 gigabytes, the enthusiast tier, a 3090 or 4090. Still no. This is the tier where a 32 billion parameter model is a comfortable daily driver. You're about 6 times short. 48 gigabytes, dual cards, or a high memory Mac, number 3 times short. 128 gigabytes, a serious workstation, a top specification Mac Studio, a multi-GPU rig. Now you're in the conversation, and depending on your quantization and how much context you want, it may fit or may be just barely out of reach. This is the first tier where the answer is maybe carefully. 192 gigabytes and up. Yes, comfortably. And at that point, the 13 billion active parameter count pays off enormously. You get large model knowledge running at small model speed. So the honest headline for the overwhelming majority of people watching this, running V4 Flash locally at full weights, is not happening on your current machine. I'd rather you hear that in minute 6 than discover it after a 2-hour download. And I want to be clear about why that's not a failure of the model. 284 billion parameters at 13 billion active is a fantastic ratio. For anyone serving this model, a company, a hosting provider, a research lab, it means dramatically lower cost per token than a dense model of comparable capability. The efficiency is real. It's just efficiency aimed at the people running inference infrastructure, not at your laptop. Those are different customers, and this model was built for the first one. The exception, expert streaming. There is one route that changes the arithmetic, and regular viewers know it well. Expert streaming, the technique we covered in depth with COLIBRI, exploits exactly the property we've been discussing. If only a small fraction of the model activates per token, you don't strictly need all of it in RAM at once. You keep a small resident core in memory and stream the active experts off a fast SSD on demand. That's how we showed a 744 billion parameter model running on an ordinary laptop with no GPU at all. The same principle applies here, and V4 Flash's ratio makes it a good candidate. The honest trade, unchanged. It's slow, measured in seconds per token rather than tokens per second, because your SSD is orders of magnitude slower than your RAM. It is not a daily driver. What it is a way to actually touch a model your hardware has no business running, for a task where you can set it going and come back. So if you want to run V4 Flash locally on consumer hardware and you're willing to wait, that's your route, and the full breakdown is linked below. If you want it to answer in 3 seconds, keep watching, because the next section is for you. Every legitimate free way to use it, the part that actually gets you to the model today. Since local is off the table for most of you, here's how to actually use this thing. Everything here is officially offered by someone. Nothing asks you to bend anyone's terms. Route 1. Deepseek's own platform. They run an API with published free allowances for new accounts, and a chat interface you can use in a browser with no key at all. That's the fastest path to an honest first impression. 2 minutes, no setup, no card. If you want to know whether this model is good for your work, start there today. Check their current published limits yourself rather than trusting any figure from a video, including this one. Free tiers resize constantly, and a number I record this week is a liability by autumn. Route 2. Hosted inference providers. This is the important one for open weight models, and it's the route most coverage undersells. Because the weights are open, anyone can serve this model, and a competitive market of inference providers does exactly that. Several carry free tiers or trial credits. And this isn't hypothetical. The gateway registry I searched before recording documents live free pools for exactly this model at more than one host. Check each host's current terms yourself. The pools resize, but they demonstrably exist today. That competition is the actual gift of an open license. With a closed model, one company sets the price and there is no alternative. With an open one, a dozen providers compete on price and speed, and you can switch by changing a base URL. That's structurally better for you permanently. Route 3. Gateways. The approach we've covered extensively, a free MIT licensed gateway that runs on your machine, presents one endpoint, fronts hundreds of providers, and does quota-aware automatic fallback when a free pool empties. If you want v4 Flash alongside a dozen other models in your editor without juggling keys, that's the route. One base URL, one key, and the gateway plays free tier Tetris underneath. And the practical setup, which by now you can predict, Deepseek's API is OpenAI compatible. So integration is a base URL and a key in whatever you already use. Your VS Code extension, your terminal agent, your own scripts, no SDK, no adapter. 2. Standing cautions. Read the data usage terms before sending anything sensitive. Free tiers are often free, precisely because usage helps improve the service. And don't build a production pipeline on a free allowance. They're sized for people, not pipelines. The million token context window, what it's actually for. Big context numbers get quoted constantly and understood rarely. So, concretely, a million tokens is roughly a few thousand pages of text, an entire codebase, a year of documentation, a very long book with room to spare. 3 things that genuinely unlock. Whole repository reasoning. Instead of retrieving fragments of your codebase and hoping the right ones came back, you put the whole thing in and ask a question that requires seeing how the parts connect. That's a categorically different kind of answer. Long document work without chunking. Contracts, filings, research collections analyzed as one continuous thing, rather than in slices that lose the thread between them. Very long agent sessions. An agent that works for hours accumulates enormous context. Large windows are what keep it coherent instead of gradually forgetting what it was doing. And the honest caveats. Because big context is one of the most oversold specifications in this field. Models are typically better at the beginning and end of a very long context than the middle. It fits is not the same as it's fully used. Long context is also expensive in time and memory. And most practically, a well-chosen 10,000 tokens usually beats a lazy million. Windows this large are a safety net for when you genuinely can't pre-select, not a substitute for thinking. A warning about what you'll see next, Distilled is not the same thing. Within days of any release like this, your feed fills with videos titled Run Big Model on your laptop, and a large share of them are quietly showing you something else. Here's the distinction, because it'll save you from a confusing afternoon. A distilled model is a smaller model trained to imitate a bigger one's outputs. It often carries some of the parent's style and strengths, and it can be genuinely excellent. This is legitimate, valuable work, not a scam. But it is a different model with a different parameter count. An 8 billion parameter distillation of a 300 billion parameter model is an 8 billion model. It fits on your machine precisely because it is not the thing in the headline. A quantized model is different again. The same model with its numbers stored at lower precision. 4-bit is the sweet spot we keep recommending. Genuinely the same model, genuinely smaller small quality cost. That's the honest compression. So when you see Run v4 Flash locally on 16 gigabytes, check which of 3 things is being shown. The actual weights quantized, impossible at 16 gigabytes, per the arithmetic we just did. A distillation plausible and worth trying. But say so, or expert streaming off an SSD, real and slow, and it should be labeled. The tell is always the parameter count. If the video never states it, that's your answer. Ask what's actually loading into memory, and the marketing collapses into arithmetic every time. None of this makes distillations bad. Some of the best local models of the last 2 years are distillations, and one from this release may become the version most of you actually use. Just know which thing you've downloaded. how to test it properly in 20 minutes for free. Since most of you will be reaching this through a hosted route rather than local, here's how to get a real answer about whether it's worth your attention. Today, at zero cost. Step 1. 5 real tasks, not puzzles. Pull 5 things from your actual work: the function you need refactored, the document you need digested, the long file you need reasoned about. Step 2. Run them through whatever you use now and save the outputs. That's your baseline. Without it, you're comparing against a memory, which is a famously unreliable instrument. Step 3. Run the same 5 through V4 Flash via the chat interface or a free API allowance. Same prompts, no coaching, no re-rolling until it wins. Step 4. And this is the whole thing. Use the long context deliberately on at least one task. This is the model's actual differentiator, so testing it only on short prompts tells you nothing about why it exists. Give it the entire file, the whole set of documents, the full module. If it's going to beat your current setup anywhere, that's where. Step 5. Judge by edits, not by vibes. Which output would you actually ship with fewer changes? That's the only benchmark specific to you. And it's worth more than every leaderboard, because no leaderboard runs your workload. And be genuinely willing to conclude not better for me. That's a completely legitimate and useful outcome. It saves you a migration, and it tells you your current setup is doing its job. The point of testing isn't to find a reason to switch, it's to find out why the license matters more than the benchmarks. I've deliberately given you no benchmark scores in this video. Here's why that costs you less than you'd think. Benchmarks for a model released this week are the least stable information about it. Vendor numbers are selected, independent evaluations take days or weeks to arrive, and the leaderboard position of any model in 2026 has a shelf life measured in weeks. Because something else shipped, MIT licensing doesn't expire. Think about what that permission actually contains. You can download the weights and keep them, and the copy on your disk cannot be deprecated, repriced, rate limited, or withdrawn by anybody. You can run it in an air-gapped environment where no API is reachable. You can fine-tune it on your own data. You can build a commercial product on it without a licensing negotiation, and you can serve it yourself or choose among the providers competing to serve it to you. Every one of those is a permanent property. The benchmark score is a snapshot. The license is the structure. And set today's release next to what we covered yesterday. A 2.4 trillion parameter model announced with no benchmark table, no license, no active parameter count, and open weights promised without a date. Same month, same scale of ambition, opposite directions. One published a number. The other published files. Only one of those can be independently checked, and only one of them is yours. That contrast is the whole story of OpenAI in 2026, and it's why I'll take a permissive license over a leaderboard position almost every time. When would you actually reach for this? Practical guidance, 4 cases. If you need enormous context on a budget, this is a strong candidate. The combination of a very large window with an efficient, active parameter count is exactly the shape that makes long context work economically sane rather than eye-watering. If you're building a product and worry about vendor lock-in, an MIT license model you can self-host later, even if you use a hosted provider today, is genuine insurance. Your fallback isn't negotiate, it's move. If you have serious hardware, this is a legitimate local flagship at the workstation tier, with the ratio to run fast once it fits. If you're on a normal machine and just want good local AI today, honestly, this isn't your model, and that's fine. The 27 to 32 billion class runs beautifully on a 24 gigabyte card. Keep that as your daily driver and reach V4 Flash through a free hosted route for the occasional heavy task. That's the 80-20 split we come back to every week. The honest limits, 4. 1. I have not independently verified this week's announcement details. I've told you the architecture and done the arithmetic, both of which I stand behind. The release specifics, availability status, pricing, benchmark claims, you should read from Deepseek's own documentation linked below. If something in this video conflicts with their docs are right. 2. Open weights and you can run it are different claims. This is the entire point of the video and worth stating flatly. A permissive license is genuinely valuable, but it doesn't add memory to your machine. Celebrate the license for what it is, permanence and optionality, not as a promise about your laptop. 3. Flash is a positioning, not a modesty. This is the efficient member of a family. It is not built to top leaderboards, and evaluating it as though it were will give you a distorted view. Judge it on throughput, context, and cost, the axes it was designed for. 4. Everything about the ecosystem is about to change. Quantized community versions, distilled smaller variants, provider price competition, tooling support. All of that arrives in the weeks after a release like this, and much of it will change the hardware answer I just gave you. Distilled derivatives in particular may put something with this model's flavor on hardware you actually own. Watch for them and verify what they actually are, because distilled from is not the same as is. Step back, because there's a pattern here worth naming. We keep having the same argument in different costumes. A model launches. The headline is a parameter count. The community asks, can I run it? And the honest answer is usually not that one, but here's what you can run. And here's how to reach the big one for free anyway. That gap between what's announced and what's runnable is where most disappointment in this field lives. It's also, quietly, where most of the progress is happening. Expert streaming putting enormous models on laptops, active parameter ratios improving every release, quantization getting nearly lossless, distilled variants arriving within weeks. The frontier of what's possible moves slowly. The frontier of what's possible on your machine moves extremely fast. And underneath it, the thing that makes any of it matter, a model you can download is a model 100 people can compress, distill, and serve competitively. A model behind an API is whatever one company decides it is, for as long as they decide it. So the answer to the question in the title is, probably not on your hardware, and that's fine, because if the weights check out, it's yours anyway. And the ecosystem that grows around an open model is what eventually puts it within reach of the rest of us. So here's my question, and I'll pin it below. What's the biggest model you've actually got running, and on what? Not what you've read about, what's on your disk, answering prompts right now, and what hardware it's on. I want real configurations from real machines, because the honest map of what's runnable gets written by people running things, not by people announcing things. And if you're on the workstation tier and you've put V4 Flash through real work, tell us what you found. That's the independent data nobody has yet. Every link, Deepseek's API documentation, their model repository with the actual license, the free access routes, our expert streaming breakdown for the run it anyway path, and our hardware guide so you can place yourself on the tier list is in the description. Verify everything I've said. That's the entire point. That's the standard here, the real explanation, sourced in plain English with the arithmetic shown and the limits named rather than skipped. If you'd rather own your tools than rent them, subscribe. That's what we do every single day. I'll see you in the next one.